Alright, today's lesson is the last lesson for this year. Wednesday, Thursday, and Friday we will review, and tomorrow, of course, is field day. So, permutations is the last thing we're going to cover before your final exam. Not too difficult, so I'm going to make it short and sweet. Alright, first, right here, lunch. Christina, Mulan, and Sophia are standing in line for lunch. Number 1 says, draw a tree diagram to show all the possible arrangements of the 3 students. I'm going to represent these by C, M, and S. Okay, so let's see how many different ways we could arrange this. Alright, so if I've got Christina, then it could either be Mulan or Sophia next. And then obviously if it's Mulan second, this is going to be Sophia. And if it is Sophia second, this is going to be Mulan. Alright, if I put Mulan first, then it's either going to be Christina or Sophia. And the opposite will be last. And then if Sophia is first, I could have Christina or Mulan. And then the opposite. So to figure out how many different ways these students could line up, I'm going to count over here. How many different possibilities do I have? So 1, 2, 3, 4, 5, 6. There are 6 different ways that these girls could stand in line. Alright, now it says describe another method for finding the number of arrangements. We're going to go over that now. That's called a permutation. Okay, so when deciding the number of ways the students can line up, order is important. Okay, we care which one comes first, which one's in the middle, which one's at the end. An arrangement or listing in which order is important is called a permutation. If order is not important, it's called a combination, and we might look at that on Wednesday a little bit, or you'll get it in statistics in high school. Alright, so in all these problems, our order is not going to matter. Our order is going to matter. Alright, so find a permutation. An ice cream shop has 31 flavors. Carlos wants to buy a 3-scoop cone with 3 different flavors. How many cones could he buy if the order of the flavors is important? Okay, so if there's 31 choices, then for the first scoop, he's going to have 31 choices. For the second scoop, he doesn't want that flavor, say it was vanilla that he chose first, so now he only has 30 choices. If he chose strawberry for the second one, then he doesn't want vanilla or strawberry for the third one, so now he's got 29 choices. So 31 times 30 times 29 gives us 26,970 different cones that Carlos could buy. So now if you look down here in symbols, make sure you write this down in your notes. The symbols P313 represents the number of permutations of 31 things taken 3 at a time. So this is the permutation of 31, choose 3. So I'm going to start with this first number, 31. That's how many different options I had. So notice I started with 31. 3 tells me how many I'm going to choose. So that tells me I need 3 numbers over here to multiply by each other. So 31, 30, and 29 gives me 26,970 that I'm looking for. So I'm going to start with my first number, and then I'm going to write however many numbers are listed second, always taking 1 away. Okay, that's how a permutation works. So let's look at this. In a race with 7 runners, in how many ways can the runners end up in first, second, and third place? So it matters. If you're in first place, you want first place. You don't want third place. So let's see, I've got a permutation. The total number of runners is 7, so that's how many I can choose from. And I want to choose 3, first, second, and third. So choose 3. Alright, so working that out, I'm going to start with 7. And I need 3 numbers to multiply by each other. So 7 times 6 times 5. Alright, so when I multiply that together, 7 times 6 times 5 gives me 210 ways. Alright, so I start with 7. I need 3 different places, so 7 times 6 times 5, and I get 210. Next example, right here we've got in how many ways, there are 10 players on a softball team. In how many ways can the coach choose 3 players for first, second, and third base? Alright, so on this one I've got a permutation. I've got 10 total players and I need to choose 3 spots. Don't know why it's always 3 on these, but it is. So 10 times 9 times 8. Now it's not always going to be choose 3. It just so happens in these examples that it is. Okay, so when I multiply that, I get 720 ways. You wouldn't think that with 10 players there would be so many different ways to choose first, second, and third base, but there actually are. Alright, so over here we're not dealing with word problems. They actually give us the permutations. So P12, choose 2, tells me I'm going to start with 12, and I need to multiply it until I have 2 numbers. So 12 times 11, which gives me 132. Alright, so I start with my first number, multiply till I have the second number, and then actually solve it. Alright, looking at the next one, we've got P of 4, choose 4. Okay, so I'm going to start with 4, and I need 4 numbers. 4 times 3 times 2 times 1. Alright, so when I multiply that, I get 24. So the answer to part C is 24. Next one, on example D, P of 10, choose 5. So I'm going to start with 10. Multiply down until I have 5 numbers. 9, 8, 7, 6. About to go off the screen. Alright, so 10 times 9 times 8 times 7 times 6. And when I multiply that, I get 30,240. Alright, so notice if the numbers are the same, like in C, then I'm going to start with my number and multiply it all the way down until 1. If the numbers are not the same, like right here in example D, 10, choose 5, I'm not going to go all the way to 1, because I'm only going to go down till I have 5 numbers to multiply. Alright, here we go on E. Consider all the 4-digit numbers that can be formed using the digits 1, 2, 3, and 4, where no digit is used twice. Okay, so that's right here. Probability of 4, choose 4. We just worked that out. 4 times 3 times 2 times 1 is 24. Okay, the next part. Find the probability that one of these numbers picked at random is between 1,000 and 2,000. So right here we've got this hint. How many of the 24 begin with the number 1? Okay, so let's think about this. If I've got 4 numbers in a row and there's 24 possibilities, then how many of those are actually going to start with the number 1? What could I divide by to see how many of them start with our number 1? Since there are 4 possibilities, I could divide by 4 and see that 6 of them are going to actually begin with number 1. So right here, how many of the 24 begin with 1? That would be 6. So to find this probability, I'm going to take the number that's possible for actually happening, so 6, over my total number, which would be 24. I can simplify this and get 1/4. Okay, now you could also make that a percent. 0.25 is when you divide it, you get 0.25. Moving it 2 places to the right, I get 25%. Don't forget how to change fractions to decimals to percent. It's very important. Alright, I think there's only one on your homework assignment or your classwork assignment, number 6, that's like this one. So you probably want to look back at this when you work at number 6 on your assignment. All right, so now your assignment is page 653 in your textbook, 1 through 18 all. Now, these should not take very long, okay, because some of them, 2 through 5 and 11 through 18, they simply give you the permutation. You just have to work it out. So as long as you have a calculator, it should not be a big deal. This is due by the end of class, okay, due by the end of class. Today we're on regular schedule, so you have got less time than you have in the past few weeks to actually get this done. So make sure that you are doing what you are supposed to be doing. See you tomorrow.